system has 120 mm thick slab supported on beams. The width of beam is 300 mm. That means width is given, but effective width of flange is not given here. And effective depth is 580 mm. The beam is reinforced with 8 bars of 20 mm diameter. Use M20 grade of concrete and Fe 415 steel. The beams are spaced 3 meter center to center. The effective span of beam is 3.6 meter. So, as per question, we have some given data, that is BW, width of web, that is 300 mm, depth is 580 mm. Now we can calculate area of steel because number of bars and diameter of bars are given. So area of steel is 8 into pi by 4 into 20 square, where 20 is diameter of bar and 8 is number of bar. That is equals to 2513 mm square. Now, depth of flange is 120 mm, that is also given. Length is 3.6 meter, that means 3600 mm, that is also given. So first of all, we have to find out effective width of flange, small b suffix f. So the formula as per IS 456-2000 for effective width of flange for T-beam is BF is equals to L0 by 6 plus BW plus 6 DF. For simply supported beam, here L0 is equals to L, that is equals to 3.6 meter. So BF is equals to 3600 by 6 plus BW, that is 300, plus 6 into DF, that is 120 mm, that is equals to 1620 mm. Now clear span of the slab to the left and right of beam is 3000 minus 300. The clear span is 3000 and 300 mm is the width of web. That's why we have to deduct 300 mm to get left and right side, means total width of only flange, that is 2700 mm. So BF should not greater than 0.5 into L1 plus L2 plus BW. So that is equals to 0.5 into 2700 plus 2700 plus 300, that is equals to 3000 mm, and our calculated BF is 1620 mm. So this is not greater than 3000 mm. Now we have to find out depth of neutral axis. Now first of all, assuming neutral axis to fall in the flange, after that we have to check out is the neutral axis fall in flange or not. XU is equals to 0.87 Fy into AST by 0.36 FCK into BF, that is equals to 0.87 into 415 into 2513 by 0.36 into 20 into 1620. So from this equation, XU is equals to 77.8 mm, which is less than DF because the DF is 120 mm. So our assumption is right and neutral axis lies in flange. Now XU max is equals to 0.480 for Fe415 steel, that is equals to 0.48 into 580, that is equals to 278.4 mm, which is greater than XU. That means this section is under reinforced section. Okay, now we have to find the moment of resistance as per the formula which is given in Annex G of IS 456-2000, that is mu is equals to 0.87 Fy into AST into D within bracket 1 minus AST into Fy by BF into D into FCK, that is equals to 0.87 into Fy, that is 415, into AST, that is 2513, into D, that is 580, within bracket 1 minus AST, that is 2513, into Fy, that is 415, by BF is 1620, into D 580, into FCK 20. So from this, by after putting these values, we can get the value of mu, moment of resistance, which is asked in our question. So mu is equals to 496.61 into 10 to the power 6 Newton mm. That means mu is equals to 496.61 kilonewton meter. So this is the answer of our problem. In this case, neutral axis lies in flange. So let's solve the next problem. Let's read out the problem first. An isolated simply supported T-beam has a flange width of 2400 mm and flange thickness of 120 mm. The effective span of beam is 3.6 meter. The effective depth of beam is 580 mm and its width 300 mm. It is reinforced with 8 numbers of 22 mm diameter bars. There is printing mistake, the bar diameter will be 22 and the grade of steel is Fe415. Now determine the moment of resistance of the section, use M20 grade of concrete. Now first of all, we have to write our given data which are given in question. Small b with the flange is 2400 mm, that is given. Depth of flange 120 mm, that is df. Small b suffix w, width of web is 300 mm, and small d effective depth is 580 mm. Now we have to find out area of steel for each numbers of 22 mm diameter bar. So for that, 8 multiplied by pi by 4 multiplied by 22 whole square. So that is equals to 3041 mm square. FCK is given for M20 grade of concrete 20 Newton per mm square and Fy is 415 Newton per mm square for Fe 415 bars, and L is 3.6 meter, or we can write 3600 mm. Now we have to find out effective width of flange. We have to use the formula for isolated beam, because in this question that is mentioned it is an isolated T-beam. So BF is equals to L0 by B plus 4 plus BW. Here L0 is equals to L because this is simply supported, that is equals to 3600 mm. So BF is equals to 3600 by 3600 by 2400 plus 4 plus 300, that is equals to 954.54 mm, which is less than the actual width, that is 2400 mm. So effective width of flange is 954.54 mm. Now we have to calculate depth of neutral axis. Now assuming neutral axis lies in the flange, so every time when we calculate this, solve this type of problem, first of all we have to consider the neutral axis is lies in flange. After that we have to check it is lies on flange or lies in web. So for this consideration, XU is equals to 0.87 Fy into AST by 0.36 FCK into BF, that is equals to 0.87 into 415, that is Fy, into 3041, that is AST, by 0.36 into 20, that is FCK, into 954.54, that is BF, which is equals to 159.75 mm, and which is greater than DF, depth of flange, That means our over assumption was wrong. That means neutral axis in this case lies in wave. So now we have to take another consideration. The value of